square x or tan square theta, and you differentiate both sides with respect to theta now. So differentiation of tan square, now watch, we use the normal rule side, right? So tan square is 2 tan theta times, we differentiate tan theta, chain rule please, which is a sec square theta. Done. So if the question looks like this, that should have been my answer. So question is exactly same apart from the 2. So introduce a 2 there, multiply by half. So if you need to write the final answer now, we copy that half, which is extra there, and the answer for that is the guessed part, which is a tan square theta and plus c. Okay, so these are very nice sums, easy to see and guess what is happening. Do you fancy this? It says integrate 3x and x square plus 5 square root, right? We have not done any question based on square root up to now. Please understand, let's make the question look like the x to the power n, like, okay, function x to the power n. So what I want to do, let's write 3x as a 3x, remove the root and write that as a half. So inside the bracket is x squared plus 5. Does it look like that standard pattern or not? We'll see. So that's a n, okay, great. Now differentiate the bracket, just the bracket only. So x squared becomes 2x. I already have x. Only a 2 is missing. That can be solved later. So yes, we have the same pattern. So we do let, take the bracket, y equals to, x squared plus 5. C, we have to increase that by 1. So half plus 1 is a 3 over 2. And we differentiate on both sides with respect to x. So we will have dy over dx is equals to 3 over 2 comes back to the front, bracket, then 3 over 2 minus 1, which is a half, c, that comes back, and this is x squared plus 5. Times, we differentiate the bracket, the chain rule please, which is a 2x. Watch there, the 2's actually cancel out. Basically, we got exactly what they have in the given question. So this is 3x and bracket half there, inside the bracket x squared plus 5. So we guessed the answer. To see whether we are right or wrong, we differentiated it, we got the question. So if you integrate this, you're supposed to get that as the answer. This time we don't need to introduce any number, not necessary, right? Because it's exactly same. So the answer is simply y equals to, there's no y, x squared plus 5 to the power 3 over 2 and plus c. Okay people, guessing sums, very, very important please, right? Look at the pattern. If you feel that, okay, I differentiate the bracket, if I get this, not exactly, if a number is missing, don't bother. That comes back in the end, right? We have one question with e to the power x there. That's what it is. Does it look like the same pattern or not? We'll say. There is a cube. We need two functions next to each other. So let's write this as e to the power 2x in the front, and inside the bracket means take this bracket to the top there, numerator. So e to the 2x plus 2, right? The 3 becomes a minus 3, that we know, okay? Now try. That's n, so okay. Differentiate this. E to the 2x is e to the 2x. Of course, there is a 2 that we will solve. Done. So our job is to guess now, right? So let y equals to bracket, increase that by 1. Watch out, increase. So it's not minus 4, it's a minus 2, right? Minus 3 plus 1. So e to the 2x and plus 2, guys, done. Differentiate on both sides with respect to x and see what happens. So it's a dy over dx equals to minus 2 comes front, right? Bracket minus 2 minus 1, which is a minus 3, and that comes back e to the 2x plus 2. But please understand, chain rule, we need to differentiate the bracket, please. E to the 2x is e to the 2x, you differentiate 2x again, which is times 2. So finally, we have minus 2 times 2, which is a minus a 4, and bracket minus 3 on top, e to the 2x, and plus 2 is there. Sorry, there is a e to the 2x, please. Okay. So the question is exactly same, isn't it? Apart from that minus 4, right? So we introduce a minus 4 and we multiply by a quarter. So let's write a minus 4 there and a minus quarter, sorry, right? So what's the answer now means the guessed part. But that quarter comes back, don't leave it please. So it's minus 1 over 4 bracket e to the 2x and plus 2 and to the power minus 2, right? Please understand this minus 3 is nothing but a cube at the bottom. So the question and that step are exactly same. So these are guessing style. Okay, we have 2 more. And then there is another method actually to do. So, yeah. X e to the x square, that's how the question looks like. Now this type of ones, we don't need to compare at all. We can easily tell by looking at the question. Take this, for example, right? Differentiate it. So let's just say, let y equals to e to the power x square. Okay. Now if you find the differentiation with respect to x, we are saying e to the something is e to the same thing square, please. But we differentiate that, chain rule, so that's a 2x. So watch the question and this. It's exactly same apart from the fact that the 2 is missing. So put a 2 there and multiply by a half. Right? So if that is the question now, if you integrate this, you're supposed to get e to the x square. So the answer is half is a half, right? And e to the x square and plus c. That's how you write the answer, right? Missing numbers, we don't need to bother, right? These are second type, right? The first type is the function x to the power n style. This also, just say, what if I differentiate this? Just check there. Differentiation of sine x is cos x like. So let's let y equals to, copy that down and say e to the power 2 sine x and differentiate on both sides. So we have dy over dx is equals to e to the something is e to the same thing, 2 sine x, and then we look at that something and we differentiate it. So 2 sine x differentiation is 2 cos x, right? So it looks like 2 cos x times e to the 2 sine x, which is our question. And a 2 in the front is missing, so write a 2 there and multiply by a half. Do not forget that. So what's the answer, guys? Means whatever you guessed is the answer with that fraction. So it's a half e to the power 2 sine x and plus c. So these are guessing style sums. We did 7 questions. There is one here. I want you to try this, please. We have lovely question. It's not theta or x, and that's at 2x, please. Just be careful about the reverse of the chain rule. Sine cube, so we can write that as sine 2x, bracket, and then a cube, right? Cos 2x stays in the front. Integrate dx. So that looks like function x to the power n. Please try this, and if there is a number missing, we can insert that. Right, I will solve, but you finish first and then check the answer. So let y equals to sine 2x to the power 3 plus 1, a 4. Differentiate, so dy over dx is equals to 4 times bracket to the 3 inside sine 2x, no change there, and then we differentiate the bracket, please, which is cos 2x and we differentiate the 2x, which is times 2, right? Simplify the whole thing and see what we get. So it's 4 times a 2, 8, and cos 2x, bracket and a cube there, inside is sine 2x. Guys, listen, that is exactly same as this. 8 is the only thing missing. So 8 in the front and an 8th. Our answer now is an 8th, the guessed part, with the 8th. So it's an 8th sine 2x and to the power of 4, right? And plus c. That's all we do. So they are not bad. They are easy questions. Sometimes you may not see two functions, right? They join them together. We can split, write them as two different functions or same, and then we can solve that. There is one here which says sine cube x. We are solving by this guessing style, right? But these questions can be done by substitution or, so many types. Let's take sine cube x. How do we do this now? Means let's split this as sine x multiplied by sine square x, suppose. Right? Then, is it looking like the shortcut that we did? Let's differentiate just the sine x. Do we get sine? No. So what we do, keep the sine as sine only. Write this as 1 minus cos square x dx. Integrate. Let's open the bracket and see what happens. Sine x times 1 is a sine x. We can integrate that, no problems. Minus sine x times cos square x. This is the part that we can guess the answer, right? Because that's a whole square, and you differentiate the cos x, you're supposed to get minus sine, right? So integrate that separately now and see what happens. That can be done, so I'm ignoring that for the time being. I'm going to choose let y equals to cos cube x, right? We increase that power by 1, please. And dy over dx is equals to cos cube x is 3 cos square x times, differentiate the cos x, which is minus sine x. So I will write sine x there and a minus in the front. Okay, if this is that, then our answer is this. Minus 3 is missing. Minus is already there. But let's write a minus 3 there, right? To compensate, you divide by minus 3. So it's 1 over minus 3. All right? Then we can easily write the answer now. So guys, now we know it's a minus 3 sine x cos square x is that. So the answer is cos cube x for that. Of course, that 1/3 comes back. I'm going to integrate the sine x now so that we know which is a minus cos x. So that comes back. The minus and the minus become a plus, 1/3, and guessed answer was cos cube. So we will write that as a cos cube x and plus c, right? So even if the question it doesn't have two functions, we split and then maybe somehow get to that level. That's the sine cube x. We did even sine 4x also. There is one for you. There's a cos cube. I will leave this question with you guys, right? You know how to split that as we did in the previous case. So that's a cos x, and inside the bracket cos square x, and then you write cos square x as 1 minus sine square x. Then you can solve the question as you did this one. So the patterns, right? Guessing style. The first type is finished. There is another one now, which says which involves natural log x or natural log something. That's the last part. All right. That is here. Now this is how the question looks like. This time it's a fraction, right? Numerator is f dash x, denominator is function x. So what is happening here is, your question will have a fraction. If you differentiate the denominator, maybe you get the numerator. Then your answer is natural log function x. That's what they said, right? Is it correct or not? We find out using our own style. So there is a question here now, y equals to ln 2x plus 5. Let's find dy over dx, right? Differentiation of natural log something is 1 over the same thing, right? 2x plus 5. Then using chain rule, we differentiate that. So times differentiation of that is 2, which is exactly 2 divided by 2x plus 5, isn't it? So that's the gradient, which is dy over dx. What we are saying is, now compare this. If the bottom one is a function x, the denominator, the numerator is actually f dash x now, isn't it? You differentiate this, you get that. Then what they are saying to us is, this is the answer. Natural log function x, the denominator. That makes sense now, isn't it? If you integrate this, you're supposed to get that because you differentiated that to get this. So that's the concept, right? So any question of that type can be solved. Quickly, if you look at integrate, denominator, write whatever comes to your mind, right? Say x cube plus x square, suppose. Differentiate this. Numerator is a 3x square and plus 2x, isn't it? So numerator looks like f dash x, denominator looks like a function x. When you integrate, what they are saying to us, what the book says is, the answer there should be simply natural log function x, which is that. So that's modulus, please, x cube plus x square and plus c. All right, so that's the last shortcut there. So you can see the question and guess the answer if it's in that pattern. I'll give you a few sums to do. You can just tell the answer by looking at the question. The first one. Got it? Differentiate the denominator, which is a 3x x square. So the answer is ln x cube plus 1. Please watch, that's natural log function x and plus c. Done. Okay. This one, happy? Differentiate this. Let's see. 2x minus 5, of course, yes. So the answer is now natural log denominator inside the modulus, please. Plus 6 there and plus c. So they are easy questions. Sometimes a number will be missing, but we can introduce that as we have done many questions of that nature. There we go. 4x cubed minus 1. Differentiate the denominator. I normally do that to see what happens. 4x cubed minus 1. A quick look, right? Y dash is a 12x square. That's it. I'm supposed to have a 12x square there. 12 is missing, so it's 1/12. So the answer now is 1/12. Don't forget that. Natural log denominator, which is 4x cubed and minus 1 plus c. Okay, so that's natural log stuff. This looks okay to us, right? Differentiation of this is a 2x plus 2, right? So we are supposed to have a 2x plus 2. A 2 is missing, so maybe we can times it by 2 there, becomes 2x plus 2. So we divide by 2 also. So the answer is now half ln denominator, which is x square plus 2x plus 3. Plus k, most important one, right? They are indefinite integrals. We can use this method to find the integrals of some of the trigonometric functions as well. Let's see. The question looks like cos x over sin x, for example. We all know cos over sin is a cot. So actually we are integrating cot x with respect to x and finding our own rule for that. Integration, just be careful there. Differentiate sin, you get cos, isn't it? Done. So that's function x, that's f dash x. So my answer is natural log denominator, which is sin x modulus and plus c. So the integration of cot theta is actually natural log sin theta. That's it. So this is a rule you can remember to solve the sums if you end up getting a cot x there. Now let's look for sin x over cos x. That's in fact is tan x dx, you all know, sin over cos. Differentiate the denominator. So f dash x is supposed to be, watch, differentiation of cos x is a minus sin x, isn't it? But we don't have a minus. So let's put a minus there and minus outside so that there is no change in the original question. Lovely. So the question is now f dash x over fx, and we are supposed to write the answer as natural log, watch there, denominator which is cos x and plus c, done, but there is a minus. That's very important, right? We'll write the c right at the end. Maybe that's an acceptable answer, but it's nice to take this to the top. It's a minus 1 in the front. So applying the logarithm rules, it should be cos x to the power minus 1. That jumps to the top there, right? What is inverse of cos, like cos to the minus 1, which is natural log 1 over cos, right? And we all know 1 over cos is actually sec theta. So that's a sec x and plus c. So the integration of tan x, a formula for that we found as ln sec x plus c. So they are given in your book, but this is how actually you solve them. If you carefully see the integration rules in C4, it doesn't include tan x, the standard functions. You got e to the x, sine and cos, sec square, cosec cot, cosec square, sec and tan, but we don't really have anything for cot and anything for tan, but this is how you can find them. I want you to try this question number 7, please, right? Here we go. Question 7 is here. Try this sum, please. Right, you solve that first and we check the answers. Denominator is a 4 sin x plus 3. We differentiate this. We get 4 cos x. That's all. So a 4 is missing. So times by a quarter. And the answer is a quarter natural log bracket denominator, please. Sin x plus 3 modulus and plus c. What about that? You know, you can do that, isn't it? Cos 4x and sin 4x, right? You can do that. Then we have one more here. Sin 2x divided by sin square x. Let's go a bit slow, right? Let's take the denominator, call it function x is equals to sin square x. Let's differentiate this and see whether we get the numerator or not, right? F dash x is equals to differentiation sin square is a 2 sin x, and then we differentiate sin, we are supposed to get a cos x. Now this is nothing but sin 2x. Please understand, that's the double angles, isn't it? So numerator is exactly same as the function x there, as f dash x. So the answer now is simply ln denominator sin square x modulus, or modulus, I mean you can take this 2 to the front and say 2 ln sin x, it's still okay. So that's natural log sin square x and plus c. You can leave like that. Just look at the double angle, please. We have one more. You know how to solve that, right? Take the denominator, differentiate it. If you get the top, great, that's the answer. If there is a number missing, you write that down. Okay, last question to go. This is the last one, then the topic is finished. Sin x cos x and cos 2x plus 3. Right, shall we do that? Right, guys, copy that and solve that first, please. So I am taking the denominator and call it function x, say cos 2x plus 3, and I'm going to differentiate that to see whether I get the numerator or not. That's a cos theta, watch there, differentiation of cos theta is a minus sine theta, which is 2x, and multiply by a 2, and that's not there, okay? So that's a minus 2. Sine 2 theta is actually 2 sine x cos x, isn't it? So together that's actually minus